Hi, this is Francis from A+ Tutoring. In this session, I'm going to solve question number 1F in the past final exam number 1. Evaluate the following integral. Now, if I have this integral right away, you see that this is partial fraction because you know that the denominator has two factors here. So you want to split it into two fractions to integrate. So how do we do this? You first look at this partial fraction into two factors. This is degree 2, this is degree 1. So I know that my x squared plus 3x plus 1 over 2x squared plus 1, x minus 3. This is equals to ax plus b over 2x squared plus 1 plus c over x minus 3. Okay, I have something like this. Now you need to cross multiply here to get into this answer. So I know that x squared plus 3x plus 1. Again, if you have trouble with this, please see my other videos related to the partial fractions. Now ax plus b multiply with x minus 3 plus c times 2x squared plus 1. Now the first trick here is to let x equals to 3. So I know that I can solve for c because if x is 3 here, this whole term here is going to be 0. Alright, so if x is equal to 3, on the left side here I have 9 plus 9 plus 1, which is 19, equals to c times 2 times 9, 18 plus 1, so also 19. So I know that my c is equals to 1. Now how about how to solve a and b? Now you need to multiply this bracket out, okay, and compare. Okay, so I know that x squared plus 3x plus 1 is equals to ax squared plus bx minus 3ax minus 3b plus 2x squared plus 1. Because I know that c is now 1, so I can just replace that. Now, if I have something like this, you have to look at my x squared value, right? This is 1x squared. I have ax squared and 2x squared. So I know that ax squared plus 2x squared must be equal to x squared. So I know that my a is going to be minus 1. Now that I know a is minus 1, how do we solve for b? B here, I can actually take a look on the bx minus 3ax or minus 3b plus 1. I'll take minus 3b plus 1. Okay, so I know that minus 3b plus 1 must be equals to my 1 here. So I know that b must be 0. Okay, so b is equal to 0. Now that I know a, b, and c, I can replace it back into here and rewrite my integral. So let's do that. So my integral is becoming integral of minus 1x plus 0, 2x squared plus 1. And then I have my plus c. C is 1 over x minus 3. This whole thing is dx. So let me double check that. Yeah, so everything is good. Now, how do we solve this two integral? You have to separate into two integral and use substitution, right? The first one here, u equals to 2x squared plus 1. I know that the u is going to be 4x dx. Please do this step because you know that you have an extra 1 over 4 here to replace what you have on top, right? And your dx. So this is very important so that you don't forget about du over 4 is replacing by x dx, right? So this is du over 4 equals to x dx. And how about on the other side here? If I replace u equal to x minus 3, I know that du is equals to dx. So there's nothing that you need to worry about here. You can just replace 1 over u here. So my whole integral is becoming, so I'll separate into two integral, right? The first one is going to be minus 1 over 4, 1 over u du. Okay, x dx is my du over 4, which mixed with my minus 1. And then the rest at the bottom is just 1 over u. And this is going to be plus integral of 1 over u here times du. Okay, the final answer here is very, very obvious, right? This is going to be equals to minus 1 over 4 ln of u plus ln of u plus c. Now, replacing u back, right? These are the different u. You have to remember, this is different, right? The u is different. So replace the correct u in the correct integral. So let's rewrite the answer right here. So I know that my answer is going to become minus 1 over 4 ln of absolute value of 2x squared plus 1 plus ln of x minus 3 plus c. And some teachers are picky, so you cannot leave absolute value here because you know that this function is always positive. So my answer is going to be minus 1 over 4 ln bracket 2x squared plus 1 bracket plus ln absolute value of x minus 3 plus c. And this is my final answer. For more information about partial fraction and this past final exam, please visit my website goforaplus.com.